Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss the basic concept of fluid mechanics. So here I covered the points, the difference between solid and fluid. Second point is what is a fluid. Third point is what is fluid mechanics. Fourth point is classification of fluid mechanics. Fifth point is application of fluid mechanics. Sixth point is dimension and units. So first of all, we discuss the learning objective for this session. First objective is basic introduction to fluid mechanics. Second is to know a various application of fluid mechanics. Third is to refresh some basic knowledge of dimension and unit. So after that session, the learning outcomes are the students will able to differentiate between solid and fluid as well as liquid and gases. Then second outcome is student will able to describe what fluid mechanics is all about. Then third outcome is student will able to handle dimensions and unit as well as derived units. So in first side we discuss here the differentiation between solid and fluid. So basically the substance is having three phases. So first is a solid, second phase is a liquid, and third phase is gases. But in case of liquid and gases we consider as a fluid. So how to differentiate between solid and fluid? So for that purpose we made on the basis of the substance ability to resist a applied shear stress that tends to change its shapes. So for if you consider a solid, when you apply the shear force or you can say shear stress, so that time it does not deform, so it can resist to the deform. So that means the solid stress is directly proportional to strain. For example, in fluid, when you are applying the shear stress, so it can deforms continuously. So that case, the fluid stress is proportional to shear strain rate. So in the next slide, the diagram shows that the pulling force, that is shear force, is applied over here. So two parallel plates is there, and in between that the eraser rubber we can placed over there. So here we can apply the force. So after that, applying the force, the solid eventually stops deforming at certain fixed strain angle. So here the alpha is a strain angle. So when you are applying the force, so it can resist up to this strain angle. But in case of fluid, when you are placing the fluid, so fluid is gases, or we can say that liquid. So when you applying the shear force, so it can deform easily. So this is the difference between fluid and solid. So it can identify easily. Now, so here the differentiating is in a different way. So first is the it solid have a tapered shapes, but in case of fluid does not taper shapes. Solid is hard and easily deformed, but in case of fluid it can softer and can easily deformed. But in case of solid cannot deform continuously under shear force, but in case of fluid it can deform continuously under shear force. So this is the differentiation between solid and fluid. Now we move for fluid. So first of all we discuss the fluid. So in case of fluid we have having categorized into liquid, or you can say gases. So liquid and gases is a fluid. So in case of liquid molecules, the it can move relative to each other. That means the molecules will move related to each other, but the volume remains constant because the strong cohesive forces will be there. So that is why the bonding will be takes place, and hence the liquid molecules move to each other. So as a result of that, the liquid takes the shape of the container. So this is the major advantage of this liquid. And here the liquid is having occupies the same shape of container. It does not compress easily and it can slides one or the other. So same case is an of gas. So it can move one or the other, but it can expands because of lack of coercive forces. So here there is no free space. So it can occupy more space into the vessel. So here it is not a definite shape because of less cohesive force. So this is the difference between liquid and gases. Now we move for what is fluid mechanics. So basically the fluid is the substance which can deforms under applied shear stress. So fluid is nothing but liquid or can say gases. Now what is my mechanics? So in science concern the behavior of physical bodies when subjected to force. So unanimously you can say that the fluid mechanics is that branch which deals with the fluid is at rest as well as the fluid is in motion and their subsequent effect of surrounding environments. So in fluid mechanics we discuss the behavior of the fluids. So here the fluid mechanics is categorized into three parts. One is the hydrostatics or can say statics, hydrokinematics or can say kinematics, and third is the hydrodynamics or can say dynamics. So first of all we discuss the statics or can say static fluid. So in a static fluid the study is like that the fluid is at rest condition and here we can study the different parameters. So example for statics or can say hydrostatics is the studying the hydrostatic forces on the dams. Now we move for kinematics. So while discussing the kinematics, the fluid is in motion, but pressure forces are not considered over here. So it deals with only velocities and accelerations, or you can say it can the study of motion of geometry. So example is like that the when a car is there, so the fluid or you can say air is moves over there over the body, so that effect or can that path will be discussed or can say path can be analyzed by the kinematics. The next is the fluid dynamics. So the fluid dynamics is nothing but the fluid is in motion, but the pressure forces are considered over here. So that is the example of dynamics. So here we discuss the different parameter for dynamics. Now we move for the applications of fluid mechanics. So first of all we discuss the first application is wind turbine. So while designing the wind turbine, we'll discuss the fluid certain amount of forces over there and then we can design. The next application is the automobile car. So surrounding the air effect on the body, it should be determined and then we go for design of automobile cars. The next we have to measure the rate of flow from open channel such as river or dam. So that time the fluid mechanics is important. The next the losses to determine losses in pipes. So here in that picture the pipe is there, so you can determine here the different losses. So that's why fluid mechanics is important. Now next is the trains. Nowadays the shape of trains are aerodynamic. In olden days it is having box shapes, so it can eliminate by studying the different fluid effects on the body. And now we move for the aerodynamic shapes. Now next important application is the aerodynamic missiles. So here we discuss the discuss the effect of fluids on the air aero, aerodynamic missiles, and then we design and development for aerodynamic missiles. Now next application is for to determine the hydrostatic forces on the dam. Then next, the studying the impeller. So while the water is entry and leaving from the section, so that time the what is the effect over the impeller. So this is also here it is important the fluid mechanics. Now we discussing different applications also here turbo machines. First of all we discuss turbo machines. Turbo machine means pump, turbine, fans, and we can say windmills. Then second application is for military. So missiles and guided missiles is there, aircraft is there, ships is there. So these effects we'll study first with the help of fluid mechanics, and then we go for designs. Then medicines in section in that heart assisted devices. This is also major application in fluid mechanics. Oil and gases. So for oil and gases industries, while designing the pump and pipelines. So these are the major applications for in a fluid mechanics. So that is importance of fluid mechanics. Now we move for units and dimensions. So what is unit actually? The it is standardized system of measurement used to describe the magnitude of dimension, and it is property that can be measured. Now what is dimension? So dimension is used to describe the body or system, and it terms to be described in quantity and assigned the numerical values. So that is the word dimensions. So first of all we categorize for units. So particulars parameter is there, length, mass, time, and temperature. So these are the particular unit properties there. So for primary quantities, length is stands for L, capital L. So we can denoting some notations. Now known second is mass. So here M is the notation. Then time is for second. So that denotation is T. Temperature it is in terms of Kelvin, or you can say the notation is in the notation is the Kelvin K. So there are three different unit system. So this is SI unit, second CGS, and third is the British standards. So for length purpose, in SI units it considers a meter, but in case of CGS we consider it in the centimeters, and in British standards we can say that feet. The mass is in terms of kilogram, CGS in terms of gram, and here the pound in British we can say that it is a pound. Then time for SI unit is seconds, CGS for also seconds, and British also is seconds. But in case of temperature, the Kelvin is for SI and CGS, but in case of British, it is in degree Fahrenheit. Now, this is the dimensions with symbols and units. So here M is for mass, L for is length, T for time, and you can say degree theta is the temperature. So these are the SI units. Now we move for derived units. So while discussing the derived units, the first terminology is the velocity. So this is second derived units. So velocity is nothing but the distance upon time, or you can say length upon time. So we know that the length is in terms of meter and time is a second. So that's why velocity unit is meter per second. So this is nothing but second derived units. Then second is the acceleration. So we know that the acceleration is nothing but velocity upon time. So as we can say that velocity into 1 upon time. So we can categorize with velocity into 1 upon time. So we know that velocity is nothing but length upon time. So length upon time into 1 upon time. So length divided by time square. So that's why acceleration unit is meter per second square, or in short we can say that meter per second square. So this is the unit of acceleration. Now we move for the third second derived units is force. So as per the Newton's second law of motion, force is equal to mass into acceleration. So that's why we can say that m into a, that is mass into acceleration. So we know that mass we can keep it as it is, acceleration is nothing but velocity upon time. So now mass is kept as it is, velocity we can keep as it is, but it is 1 upon time. So that's why we can write as a 1 upon time. So here we know that the velocity is nothing but length upon time. So velocity is nothing but length of time. So that's why it becomes mass into length divided by time square. So this is time to time square. So that's why we can give the unit like that, kg. So that for length is meter and time is for second square. So unit for the force is the kg meter per second square. So whole it is say that it is Newton. So force is in terms of Newton. Now fourth unit is energy. So previously we discussed that force is nothing but in terms of Newton. Now energy is nothing but force into distance. So force is in terms of Newton and distance in terms of meter. So for the energy, or can say work done, the unit is Newton meter, or you can say joule. So whole Newton meter is called as joule. Now we move for the power. So power is nothing but work done upon time. So we know that the work done is nothing but force into distance. That unit is Newton meter. So I can write here Newton meter and divided by time is there. So that's why I can write second. So we know that Newton meter is nothing but joule. So here we can see that joule per second, or we know that joule per second is nothing but watt. So this is the second derivative derived units. So next term is the pressure. So pressure is nothing but force upon area. So that's why I consider as in force is nothing but Newton and area is in terms of meter square. So unit is Newton per meter square, or can say Pascal. So it is the SI unit is for the pressure is Newton per meter square. So here the block indicates, or can say the table indicates the different quantities and their different SI units. So velocity is meter per second. So on the basis we can write as a meter second raised to minus 1. So we can say meter per second. Acceleration is meter per second square. Force is nothing but Newton. So Newton is the name of scientist. Then energy. So energy is one more unit is there, Newton meter, or you can say joule. So joule also is name of scientist. Then joule per second. So or you can say Newton per meter second. It is called as watt. So watt is also name of scientist. So this is the specialty of these three terms, that is force, energy and power. And now last point is the pressure, or can say stress. The same unit is there, or can say same formula is there, that is force upon area. So that's why the unit is Newton per meter square, or can say Pascal. So this is regarding the second derived units. So here we discuss the different parameters. Thank you. In next lecture we will discuss the conversion of units.